Hello guys, so in our last video we were able to make an alert when the dynamic DLL doesn't match with the static DLL, and today what we're gonna do, we're gonna add some logs here. So why do we need even logs and what does it even mean by logs? So basically this is our table and it's like global table, like every thread when the process runs can access this table. Like that process is just a container and the thread actually execute the code, but there's a difference between user mode thread and the process thread, and you can say the kernel thread. So right now this table is accessed by the kernel threads, not by the what we can say process thread. So like whenever a callback like comes from like process notify or anything else, so it will gonna like use this global table and it will gonna start a race table. So for example, if T1 like wants to find what we say a slot, and T2 or another thread of another process also wants to like access the some slot, so they will gonna rush in, and whoever like find the slot one, they're gonna enter. But sometimes what will happen, like two like threads enter the slot simultaneously, it will corrupt the memory and it will like cause the BOSD. So what we can do, we can make a global lock so that only one thread of the kernel can enter and touch the memory of the like this global structure. So what we can do, we can add some basic looks when we go in like in depth, like when our priority should be like a performance, then we will gonna study more about it and add some advanced looks. Right now, our main motive is like our EDR should be working without any error. Performance should be like we put at the last. We just need a working prototype right now. So let's start with the logs. So we're going to use fast mutex, and you're going to read about it. I already told you the function, and this is for like passive level. And when we go to the depth, then we're gonna also see that which function have passive. There's a just a single function which can also log out like which level logs we can use in there. So we're gonna use like fast Emacs. So I gonna declare here only where the table is. So let's declare it, and let's call it log because it's easy to remember. Whenever we add a log, we have to initialize it. So we also have to do that. So let's do it. And we have to initialize it like entry driver. So the driver entries. So I'm gonna initialize here, and it's take a pointer, so I have to add a pointer here and log, and we are done here. So right now the main thing is like we want a log whenever this like structure has been accessed. So whenever we add log, so there's two things here, like acquire and release. So whenever a thread gonna use this, we have to like add in the global table that uh, this thread is like acquired right now. It's just like a key. Like if thread one want to get access, it will take the key, and no one like other thread will gonna get enter inside the like structure and change the memory. They will gonna sleep and wait for their turn. So it will create a sequence out of it. So let's start, and we have to find the like in the code that where in which function we are using what we say this structure. So here we can see, so here we can see we pass the structure PS, and in this function we have to use the logs. So first of all, like in this whole like function, this for loop is using what we say uh, the structure here. So we have to add log here. So first of all, we use this function to acquire the log. So, and it's also take the pointer, so I will gonna add pointer to it and lock. And we like if we try to like add a lock inside here only this position, if I highlight this, then it will make chaos because loops like gonna run over and over again. So if we add here, it doesn't make any sense. So then we have to also release the loop, sorry, locks. Then there's another function here for the releasing the uh, lock is like this is the function here. So let's copy this and paste and give it to the pointer lock, and we are done. So we completed our first function. So like whenever like kernel thread gonna use this function, get inside it, and whenever it like it has to whenever the kernel thread has to access this part of the code, they have to like take a key from it. After using it, they have to like release the key. And in another case, like here we are using the PS structure, so also have to like first of all I have to like add some things here. I was being clumsy that I didn't add things last time, so I should have checked that if image name is null or image name buffer is null, and we can say also image info is null. If anything happens like this, then we're gonna return. So this thing is doesn't need any logs, but this thing actually need logs because it accessing the our what we say structure. So I'm gonna copy from above, acquire log, and gonna paste. Where is it? I'm gonna paste it here. And whenever we return, we have to pass the like release the key also. So I will just delete it, and if PS is null, then we're gonna release the lock and return. And another thing, so we're also using the structure here, and but you can see they inside this like if statement there is a alpha image, but we already gave the logs to the alpha image, you can see here. So if we add the logs here, it will gonna make a deadlock, so we don't want that. So to solve this problem, we can make another boolean variable here, and let's call it do parse, and make it equal to false obviously. And let's what we can say, let's delete it from here, and we're gonna make what we say do parse true. So you can see here like before parsing we can see, so if we do something like this here and make what we can do here, so if we check that if do parsing is true, then we can do the same thing here, and we can just close what we can say the lock, release the lock here. Where is it? So we are done because like the PS structure started from here, and it's also using PS structure. So this is the whole one part we can conclude it that log started from here, and like PS structure, and PS structure and log has been like released. So most of the heavy work is has been done by the alpha image because it's like passing the what we say the binary, and it will like multiple of the what we say thread gonna pass the what we say like binary. It will like stop like it will stop like making it, like to the parse. So we don't want like most of the thread to wait like just to like parse a single binary. So another thing we can see here, uh, we can just copy, cut this, and is binary is ready. Sorry, we can do it here. Static is ready or not. If ready, then we can continue. And that's it. I guess we just add logs again here. And if we are returning it, then we have to release the logs. So to release the logs, we're going to use this and we're going to return. That's it. At in the end, we're also going to return the logs. Sorry, release the logs. So I think let me check again. Um, doesn't need logs. PS find and boolean false. If it's true, we're going to pass it and return. Then we're going to say make a buffer where can we save the extracted DLL, and that's it. Then we're gonna check this static ready. Yes, it's static ready. If not, then it will return and release the log. And that's it, I guess. Let's copy this and test like is it any bugs here? No error. Let's compile this. Let me check first, is there any previous EDR is running or not? SC QC norm. Yes, it's running, so let's delete it and build. Okay, we have to like stop it also. SC stop norm and build again. And it's built, and we have to copy the location path. Let's create our let's call it create norm type kernel bin path equal to sc start norm. So Windows is working. So I think code is executed properly. There's no like crashes here right now, so it's good, and everything should working fine. And yes, everything is working fine as previously. So let's check. In the last video, we were able to like get alert properly. So let's check our POC and stop the kernel and POC. This is the POC with the PID 19156. We have to check 19156, right? 9156. 91. Okay, we are not. Here is it. So we are able to find the alerts. Everything is working just fine. And that's it. We added the log. And another thing we can do, like there are so many noise, so we can just remove what we say the basic thing, the base DLL. These are the normal DLL. Every time it works and it won't be in the what we say uh, static. So we're gonna add it. So I already compiled the code. Sorry, I already wrote the code. I will just copy it and gonna paste almost here, and I will gonna just add it to our last function. And we're gonna name DLL name Let's try to compile this. Let's stop the EDR. We already stopped SC, delete, GNOME. Let's rebuild it and try to start again. Let's see if the noise reduce or not. It won't like reduce the noise drastically, but it's like somewhat it will gonna reduce. Okay, wait. Let's start again. It's working dynamically, and so somehow we reduce the what we say the noise also. So this is our final step and we are done here. And the next topic will be like intent graph. It will take almost a month to cover some basics, and uh, I hope it will be like great learning till now. Okay guys.